Hello students, today we are going to discuss summation of series. Summation of series means is a section in the chapter of your 11th mathematics, sequence and series. There you study arithmetic progression, okay? You know how to find the sum of an arithmetic series, okay? And you study geometric progression and you know how to study how to sum the geometric series, okay? And after that you will sum, you can sum some special series also, okay? So this section is actually, the name is summation of some special series, okay? And what is the importance of this section? In all the engineering entrance examination, one question should be from this section, at least one question, okay? So this is so important. So what we need? What are the things we need to study to work out the problem of summation of series? Okay. First of all, you have to know the symbol sigma. All of you know this series, this symbol, what this symbol means, what is meant by sigma xi, I is equal to 1 to 10. This means actually I is equal to 1 we get x1, when I is equal to 2 we get x2 plus etc. okay, plus last term is x10. Of course you can write all the terms, okay. So this means sum of the terms like xi by putting I is equal to 1 to 10, sum of all terms xi when I varies from 1 to 10, okay. That is this series means, okay. And what are the properties of the series? One property is sigma xi plus yi can be written as sigma xi plus sigma yi, can be split. If it is minus also, you can write sigma xi minus sigma yi. And sigma, a constant into xi, okay, it can be written as k times sigma xi. You can take the constant outside, okay. What is sigma xi plus yi? Sigma xi plus sigma yi. And what is meant by sigma k into xi? It is k into sigma xi, okay. You can take the constant outside. And sigma I is equal to 1 to 10, 1 or a constant k. What does this mean by? This is very clear. Sigma xi means x1 plus x2 plus etc. plus x10. Then what is mean by this? I varies from 1 to 10, but in all the terms you get 1 plus etc. 10 terms, okay. Answer is 10. So first of all, you note this, okay. This is the sigma notations, okay. What else we need? We need some identities, okay. We need some identities. First identity is sum of the infinite terms of, if modulus r less than 1, a plus ar square plus etc. to infinity. That is sum of the infinite terms of a geometric progression. Of course, in your textbook, in that chapter you study sum to n terms of geometric progression. And in the textbook, the last section, there is given what is the sum to infinity of a geometric series. That is this result, okay. This equal to, the formula is a by 1 minus r, very simple formula. What is the sum to n terms? A into 1 minus r raised to n by 1 minus r. But the sum to infinite terms is a into a by 1 minus r. It is only a by 1 minus r. Sum to infinite terms of a geometric series, okay. The condition to sum infinite, modulus r should be less than 1, okay. Otherwise you can sum. 1 plus 2 plus etc. plus n. What is this? Sum of the first n natural numbers. All of you know that. Is equal to n into n plus 1 by 2. Okay, what is the sum of the first 100 natural numbers? 1 plus 2 plus etc. plus 100. 100 into 101 by 2. That is a beautiful answer. 5050. 50-50. Okay. Then what you need else? 1 square plus 2 square plus etc. plus n square. That is sum of the squares of first n natural numbers. Okay. The formula is n into n plus 1 into 2n plus 1 whole divided by 6. Okay. What is the formula? N into n plus 1 into 2n plus 1 by 6. Okay. Then we need one more formula, that is 1 cube plus 2 cube plus etc. plus n cube. Okay. And it is n square into n plus 1 whole square whole divided by 4. Actually, that can be obtained from this. N into n plus 1 by 2 square is n square into n plus 1 whole square by 4. Okay. So, we say what is sigma, what is the property of sigma, okay. Then what is the sum to infinite terms of a geometry progression, and 3 formulas like sum of the first n natural numbers, sum of the squares of first n natural numbers, sum of the cubes of first n natural numbers. Okay. Then we need one more thing. Do you hear the word AG series? What is meant by AG series? It is meant by arithmetico-geometric series. What is the name? Arithmetico-geometric series. Okay, what is meant by this? In this series, each term is the product of a term from the arithmetic progression and the corresponding term from the geometry progression. What is an AG series? The series consists of terms, okay, containing a term from arithmetic progression into corresponding term from geometry progression. Okay, see. Suppose A plus D, A plus 2D, etc. A plus n minus 1 into D. We know that all are in arithmetic progression. 1 r square, etc. r raised to n minus 1. Okay, in terms of a geometry progression. Okay, multiply each term and sum it. So what we get? A into 1, A plus D into R, A plus D into R. Then next term, A plus 2D into R square plus etc. Last term is A plus n minus 1 into D, okay, into R raised to n minus 1. This is up to n plus etc. Of course, you can sum again. This is what is known as an AG series. This is what is known as an AG series. There are questions like sum and find sum of certain terms of an AG series. So if it is not familiar with you, of course you know what is an AP, what is an GP. Okay, but you have to know what is an AG series. This is a series of name as AG series, arithmetico-geometric series. Okay, we have to know the sum to n terms of this series and sum to infinite terms of this series also. Okay. If you can remember that also, then everything from this section is over, every formula. Okay. So first sum to n terms, Sn equal to A plus D into R plus A plus 2D into r square, okay, plus etc. up to n terms. This I said. The formula is a by 1 minus r, okay, plus dr into 1 minus r raised to n minus 1 by 1 minus r whole square minus a plus n minus 1 into d into r raised to n by 1 minus r. Okay. Of course, it's a large formula, okay, and there is a method to find the sum to n terms, okay, and if you want to discuss about this formula, you can ask question in the doubt clearance section, okay. In the doubt clearance section, we can derive how we obtain this formula, okay. Now we have no time to discuss the formula, how to obtain the formula, okay. So, if possible, you can study this, it may help a lot to do problems like find sum to n terms of an AG series, a by 1 minus r, dr into 1 minus r raised to n minus 1 by 1 minus r whole square minus a plus n minus 1 into d r raised to n divided by 1 minus r, okay. And the sum to infinite terms, of course, the common ratio should satisfy the condition that modulus r less than 1, okay. Then only you can sum infinite terms. Answer is a by 1 minus r plus dr by 1 minus r whole square. What will happen to other terms? When modulus r less than 1, r raised to n becomes 0 when n tends to infinity. Okay, so we get only this. Okay, what is s infinity? A by 1 minus r plus dr by 1 minus r whole square, d into r, okay, d into r by 1 minus r the whole square. So, that is all. That is all for this chapter. That is all for a question. This is a sure question. This is an important question. Okay. So, we can go through all the results again. What is first? What is summation? I say what is a summation? What are the properties? Okay. Then, three identities. Sum of the first n natural numbers, n into n plus 1 by 2. Sum of the squares of first n natural numbers, n into n plus 1 into 2n plus 1 by 6. Sum of the cubes of first n natural numbers, n square into n plus 1 whole square by 4. Okay, then we say, what is an AG series? What is the sum to n terms of an AG series? Okay, it's a difficult formula, of course. Okay, and what is the sum to infinity of the AG series? That is simple compared to the n formula for sum to n terms. Okay, what is infinite terms? Sum to infinite terms of an AG series, a by 1 minus r plus dr by 1 minus r whole square. Dr means d into r. Okay, now we are going to discuss some past entrance engineering entrance examination question from this section. Okay, ready? Okay, see the first question. What is the question? You read the question carefully. Find the sum to series n terms, sum to n terms of the series. What is the series? Root 2 plus root 8 plus root 18 plus root 32 plus etc. You can see that they doesn't form an AP and they doesn't form a GP. It is not an AP series. That is not an AG series. Sorry, GP series. Okay, of course it is not an AG series because in AG series every term is the product of two terms. Okay, so what is in it? Just to check. Root 2 Sn, sum to n terms, okay. Root 2 plus root 8 plus root 18 plus root 32 plus etc. Just look what is in it. What is in it? It is not an AP. It is not a GP. Then what is it? Come on. This is root 2, of course. Root 2 is root 2. And root 8 is 2 root 2. Oh, that is it. Root 8 is 2 root 2. How can we write that? 8 is 2 into 4 or 4 into 2 and root 4 is 2. So we got 2 root 2. Then what is root 18? It is 9 into 2, 3 root 2. What is root 32? It is 4 into 2, 16 into 2. So 4 root 2 plus etc. In all the terms, root 2 is a common factor. Take it outside. This is equal to root 2 times. Here we get 1, here we get 2, here we get 3, there we get 4 plus etc. Okay, what is inside the bracket? That is a known term, sum of the natural numbers, and we are summing up to n terms. That is remembering this suffix. We are summing up to n terms. And what is the formula? Root 2 into n plus 1 by 2. That is the formula. Okay. What else we need? We can, of course, we can cancel this root 2 and 2 because 2 is root 2 into root 2. This root 2 will cancel. We got the answer. Last answer is n into n plus 1 by root 2. Okay? Quick, once again, we write the series and we rewrite the series as root 2, 2 root 2, 3 root 2, etc. We take root 2 outside. Inside the bracket, we get the sum of first n natural numbers. We write the formula n into n plus 1 by 2 and we cancel root 2 here because 2 is equal to root 2 into root 2. So, last answer is n into n plus 1 by root 2. Okay? Yes. Go to the next question. Okay, what is in the next question? See, next question. The sum sigma k is equal to 1 to 20, 1 plus 2 plus 3 plus etc. plus k. Okay. All of you know sigma xi. Okay. What is sigma xi? It is x1 plus x2 plus etc. plus. Okay. Similarly, can we put k equal to 1 to 20? It's not possible here. Yeah. So, what we have to do? We have to write the formula for 1 plus 2 plus 3 plus k. What is the sum of first n natural numbers? It is n into n plus 1 by 2. So, what is the sum of first k natural numbers? K into k plus 1 by 2. So, what do you need? You write the formula for the term inside the bracket. Okay. We need sum to 20 terms. Okay. This is equal to sigma k is equal to 1 to 20, 1 plus 2 plus etc. plus k. What do you need? First, before writing k equal to 1 to 20, you sum this. This is k into k plus 1 by 2. Okay. And there is a property of sigma is you can take 1 by 2 outside. Okay. And before putting k is equal to 1 to 20, you multiply k into k plus 1. Okay, first you write the formula for 1 plus 2 plus etc. plus k and you simplify that. Okay, you can write this equal to sigma k equal to 1 to 20 k square plus k whole divided by 2. Okay, now you can apply the property of sigma. The first term is 1 by 2 into, we take 1 by 2 outside because if there is a constant sigma kxi, that is a property, sigma kxi is equal to k into sigma xi. So here sigma k square plus k by 2 is 1 by 2 into, okay, sigma k square plus sigma k. Okay, sigma xi plus yi can be written as sigma xi plus sigma yi, just like that. Sigma k square plus k can be written as sigma k square plus sigma k. Okay, and what is here? All the sigma, the variable varies from 1 to 20. You need to sum 20 terms only. No need of summing all the terms. Okay, and what is this? What is sigma k square? Okay. You know 1 square plus 2 square plus etc. plus n square is the sum of squares of first n natural numbers. And that is sigma n square. That is sigma n square. Okay, so sigma k square is sum of the squares of first and natural numbers. What is the formula? N into n plus 1 into 2n plus 1 by 6. Okay, but here n is equal to 20 only. N is equal to 20 only. So we got this equal to 1 by 2 times 20 into 21 into, okay, n into n plus 1 into 2n plus 1. 41. 2 into n is 40 plus 1 is 41 by 6. That is the formula. N into n plus 1 into 2n plus 1 by 6. Okay. Plus, what is the next term? Sigma k. That is k into, here k is 20. Okay. 20 into plus 20 into 21 and into n plus 1 by 2. Now everybody can be solved this. That is all. Okay, simplify. What is the answer? This is equal to 1 by 2 times. Okay. This 6 you can write 2 into 3. 2 in 20 10 times. 3 in 21 7 times. 7, okay, 41 into 7 is 287. 287 into 10 is 2870. 41 into 7 is 1 into 7 and 4 into 7 28. Okay. Plus here these 2 cancel to 20 10 times. So 210. Okay. Divide by 5. 1 4 3 5 plus 105. And what is the sum? Sum is equal to 5 plus 5 0 and we get 4, we get 5, 1540. 1540 is the answer. This is the answer. Okay? Again, once again quickly see, this is the question. What we done first, we write the formula for 1 plus 2 plus k. This k into k plus 1 by 2. Okay, we simplify this. If there any multiplication, any addition, etc., you do that. That is the simplification means. K into k plus 1, k square plus k. And we take 1 by 2 outside. We split the sigma into both terms. One is k square, other one is k. And the most important thing is, what is mean by this? This is the sum of first 20 terms of n 20 natural numbers. This is the sum of first 20 natural numbers. This is the sum of squares of first 20 natural numbers. This is the sum of first 20 natural numbers. Okay, here the formula is n into n plus 1 into 2n plus 1 by 6. So for 20, it is 20 into 21 into 41 by 6. And here the formula is n into n plus 1 by 2. For n is equal to 20, answer is 20 into 21 by 2. We simplify, we get the answer 1540. That is the choice A. Okay? Okay. Then go to the next question. Yes, see the next question. What is the sum up to 11th terms? Okay? We need to sum only 11 terms of this series. Okay? Some may think you can find all the 11 terms and sum and find the solution. Okay? Of course, you will get the answer, but it will take time. That is the mistake. Okay? Yes. See how to do this question otherwise. Okay? We need sum of 11 terms. Okay? That is equal to 1 plus 2 into 3 plus 3 into 5 plus 4 into 7 plus etc. Okay. The most important thing like question like this is you have to feel the pattern. The question must have a pattern. Okay, see. 2 into 3, 3 into 5, 4 into 7. All the terms are product of two terms. Only the first term is only one term one. Then you have to rewrite the first term also product of two terms. How can you write? Of course, that is very easy. 1 can be written as 1 into 1. Okay? 2 into 3. 3 into 5 plus 4 into 7. You may smell that this is an AG series because product of two terms. So check first term 1, 2, 3, 4. Of course that is an AP. Check the second term 1, 3, 5, 7, etc. That is also an AP. Oh, see, that is an AG series. One is arithmetic progression, second one is geometric progression. Here the two terms are in arithmetic progression. Okay, of course you can name this as AA series. Okay, no problem. You have to write the nth term of this series. What you have to do to sum this series is you have to find the nth term of the series. Okay. That can be obtained, easily obtained from the pattern. You see, first terms are 1, 2, 3, 4, etc. So, in the nth term also, the first term is n. Okay. Second terms are 1, 3, 5, 7, etc. So, the nth term, the second term of the nth term is 2n minus 1. When put n is equal to 1, you will get 1. When n is equal to 2, you will get 3. When n is equal to 3, you will get 5, etc. If you don't write this easily, you go on the right side and find the sum of n terms of the series 1 plus 3 plus 5 plus 7, etc. Use the formula from AP. Okay, no need of that. Everybody knows odd natural number is an odd natural number 1, 3, 5, 7, etc. We write that as 2n minus 1. Okay. So, n into 2n minus 1. What is sum? Therefore, what is sum? It is sigma n into 2n minus 1. Of course, we need to simplify this. Okay. This is equal to 2n square minus n. After simplifying the nth term, we get 2n square minus n. So, you need to write that here. Okay. This is 2n square minus n. Use the property of sigma. So, you will get 2 times sigma n square minus sigma n. That 2 is only for the first term. Okay. Now, you sum and keep in mind that the summation is 1 to 11 terms only, 1 to 11 terms, okay, 1 to 11 terms, okay. So, S11 is equal to 2 into, what is the formula? This is sigma n square, sum of the squares of first n natural numbers, n into n plus 1 into 2n plus 1 by 6, but here n is 11, so we got 2 into 11 into 12 into 23. 2n plus 1, 2 into 11, 22, plus 1 is 23, by 6, okay, minus the sum of the n natural numbers, n into n plus 1 by 2, but we have only 11 terms, 11 into 12 by 2. Okay, you can simplify. Come on, do it, find the answer. You can write 6 as 2 into 3. So, 2 will cancel, we get only 3. And this 3 here 4 times. 4 into 23 is 3 into 4, 12, 92. Okay. Minus, here this 2 goes to 12 6 times, 66. Okay, 92 into 11. What is 92 into 11? Find it. 92, 92. Okay, 211, 1012, 1012 minus 66. Okay, 6, 10 minus 6 is 4. Okay, then 9. So, answer is 946. Of course, that is given here, 946. It's an easy question, isn't it? Okay. See, once more. This is the sum. We write the first term as 1 into 1 for what? That is important. For what we write 1 as 1 into 1? To keep the pattern. To keep the pattern. Everybody, if you should have a simple logic, okay, little logic in your mind, you can write first term as 1 into 1. Okay. So in all the terms, product of two terms, but it is not an AG series. It is not an AG series, okay, because all the terms are in AP. First terms and second terms form an AP. So first terms are 1, 2, 3, etc. You have to write the nth term. That is important. You have to write the nth term, UN, of the series. Then sum it using sigma and write the formula. Put n is equal to 11. Simplify. That is all. Okay. So this is 1, 2, 3, etc. is n. 1, 3, 5, etc. is 2n minus 1. Okay. And we multiply that to n square minus n. We simplify that. Okay. Then find sum. Use sigma. Property of sigma. Write the formula. Write the formula. Simplify it. That is all. Okay. You got it? Yes. Go to the next question. Okay. See the next question. This is also a similar question. A series is given. You have to sum up to 15 terms. Okay? So previous G main question. You have to find sum to 15 terms of this series. Okay. And here also you check the given series. See, from this term onwards, from third term onwards, the terms keep a pattern. Say 9, 12, 15, etc. First term. 9 plus 3, 12, 12 plus 3, 15. And inside the bracket you see 1 square plus 2 square plus 3 square, 1 square plus 2 square plus 3 square plus 4 square, and so on. Okay, and in the denominator also 7, 9, 11. 7 plus 2, 9, 9 plus 2, 11, etc. So the question keeps a pattern after second term. Okay, so we have to rewrite the first, second term and the first term the same in the same pattern. Okay. Yeah, that is the tough thing, of course. So I write from the third term plus 9 times 1 square plus 2 square plus 3 square whole divided by 7 plus 12 times 1 square plus 2 square plus 3 square plus 4 square whole divided by 9 plus etc. We need up to this. Okay. Then what should be the second term? Okay. With the second term, inside the bracket, see, this is 1 square plus 2 square plus 3 square, and here we should have 1 square plus 2 square. No doubt. Okay, everybody will agree. Okay. And here 7, 9, 11, etc. Two difference. So in the denominator, we have 5. So that we need. In the numerator, we need a term inside the bracket as 1 square plus 2 square. And in the denominator, we need 5. Okay? So you will be happy to see that in the numerator and denominator, we write 5. So they will cancel, we get 6 itself. So no harm. Okay? No problem at all. Okay, in the next, that is the first term, first we write the denominator. It should be 3. Okay? It should be 3. Oh, yes, everybody agrees. Okay. And inside the bracket, that is 1 square. Okay, that is also okay. And we have, see, 12, 9, 6, so that should be 3. Yeah, that is the first term. So it's not a difficult thing to write the first two terms, keeping the pattern. Okay. So this is S15. This is S15. Okay. What we need? We need the nth term, UN. Okay, nth term. 3, 6, 9, 12, etc. All of you know that is 3n. That's not much difficult. 3, 6, 9, 12, etc. It is 3n. 3 into 1 is 3, 3 into 2 is 6, 3 into 3 is 9, etc. Okay. And inside the bracket, it is more easy. 1 square plus 2 square plus etc. plus n square. In the first term, we have 1 square. In the second term, we have 1 square plus 2 square. In the third term, we have 1 square plus 2 square plus 3 square. So, in the nth term, there should be 1 square plus 2 square plus etc. plus n square. Okay. And in the denominator, 3, 5, 7, 9. Okay. is an AP, odd numbers, but it is 2n plus 1, not 2n minus 1. Put n is equal to 1, it is 2 into 1 plus 1, 3. First term is 3, so it is 2n plus 1. If first term is 1, you have to write it is 2n minus 1. Okay, so 2n plus 1. And this can be simplified as 3n times n into n plus 1 into 2n plus 1 by 6, that is 1 square plus 2 square plus etc. plus n square, and by 2n plus 1. So that comes here. And we are happy to cancel this. Okay? 3 by 6, 2 times. So we get 1 by 2 times n into n plus 1. It is n cube plus n square. That is un. What is it? 1 by 2 times n cube plus n square. N cube plus n square. Okay. Now find the sum. S15 equal to sigma 1 to 15. Okay. What is the sum? I remember. Un is equal to U. 1 by 2 into n cube plus n square. Okay. S15 is equal to 1 by 2 into, of course it is 1 by 2 into n cube plus n square. 1 by 2 into n cube plus n square. Okay. Okay, this is un, half into n cube plus n square. Then what we need else? Some sigma, use sigma. Okay. So, S15 is sigma 1 to 15 of un. Un is half into n cube plus n square. That is equal to half times sigma n cube plus sigma n square. Keep in mind that this half is a common factor. Okay? And what is this? Sigma n cube. Sum of the cubes of first and natural numbers. What is the formula? N square into n plus 1 whole square by 4. But n here is 15. 15 square into 16 square by 4. Not a 2, by 4. Okay. Plus, what is sigma n square? It is n into n plus 1 into, okay, 2n plus 1. 2n plus 1 is 31. Okay. Whole divided by 6. Okay, come on, simplify it. Come on, simplify it. This is equal to, of course, this is 16 into 16. So, 1 4 will cancel. We get 1 by 2 times 15 into 15 into 16 into 4. Okay. And here, of course, we can write 6 as 2 into 3. 2 into 3. And 2 will cancel in 6, 8 times. 3 will cancel in 15, 5 times. Okay. So, we get 5 into 8, 40 into 31. Okay. This is equal to 1 by 2 times this 15 into 4. You see, simple multiplication. 15 into 4 is 60. 60 into 15, 900. 900 into 16. Okay. 900 into 16. We got 14400. Okay. Plus. And 40 into 31 is 0, 12. Okay. 1240. Okay. 1240. 1 into 4 is 4 and 3 into 4 is 12. Okay. We add 1240. 0, 4, 6, 5, 1. And we have a by 2. Okay. By 2 gives 7, 8, 2, 0. 7, 8, 2, 0. Where is the answer? Oh, of course, it is here. 7820. Okay. I will say this once more. Here, the most difficult thing is we complete the pattern for the first and second term. Of course, we find it is easy, not such difficult. Okay. We consider all the other terms. Then we made a pattern for the second term and for the first term. Of course. Okay, that is it. Okay. And we write the nth term. Nth term is 3n into, that is easy. Okay. And we write the formula for sum of and sum of squares of first and natural numbers. So, conveniently this 2n plus 1 factor cancelled and is reduced into half into n cube plus n square. So, a bigger question reduced to a smaller one. Okay, half into n cube plus n square. Now, we find sigma, summation. Okay, what is next? We find the summation. Okay, S15 equal to 1 to 15 half into n cube plus n square. We split sigma, take 1 by 2 outside. We use a formula n square into n plus 1 whole square by 4, putting n is equal to 15. And here we use the formula n into n plus 1 into 2n plus 1 by 6. Here also we use the term n is equal to 15. Okay, and we simplify, we get the answer. Okay, what is the answer? What is the answer? 7820. This by 2. Okay, by 2. 7820. Okay, clear? Yeah, it's a lengthy question, no doubt. But it is not much tough. Okay, like your integration question or some other questions. It is not so tough. Okay, you need only some formulas and you have to find the correct pattern. Okay, if you have some logic, you can finish this question. No problem. Okay, you can attack questions like this. Okay, questions from summation of series. Okay, okay. Go to the next question. Okay, see the next question. Okay, is the last year G question, G main question. What is it? Sk is given. 1 plus 2 plus 3 plus etc. plus k whole divided by k. We have to find s1 square plus s2 square plus etc. plus s10 square. Again, the answer is given in terms of 5 by 12 times a, and we need to find only a. Okay? Okay, no easiness by giving 5 by 12 a. Maybe 5 by 12 is a factor of the sum. Okay? Okay, we can look. Okay, we can check. Maybe 5 by 12 is a factor of the left side. Then you can find a. Okay. But here, I think a little difference. Okay? A little difference here. No, the kth term is given. No difference. You have to find the sum up to k terms. Here the kth term is given. No need of finding the kth term or nth term. It is given here. Okay. What is Sk? What is Sk? It is 1 plus 2 plus 3 plus etc. plus k whole divided by k. Is given. And what is in the numerator? It is k into k plus 1 by 2. Of course, here is a k, okay? By k means into k. That does not come to the numerator, okay? It is again in the denominator, okay? This k and k cancelled. Yes, then this become k plus 1 by 2, very simple kth term. Okay? And we have to find the sum s1 square plus s2 square plus etc. plus s10 square. This is actually sigma k equal to 1 to 10 this sk square. Okay? Putting k is equal to 1, you will get s1 square. Putting k is equal to 2, you get s2 square. Etc. Putting k is equal to 10, you will get x10 square. Okay? This is equal to sigma k equal to 1 to 10. What is sk we obtain? K plus 1 by 2 whole square. That is it. You expand. What is k plus 1 whole square? What is k plus 1 whole square? This is equal to, okay, 1 by 4. You can take outside, okay? K plus 1 by 2 whole square. We get k plus 1 by 2 whole square. Then k square plus 2k plus 1. Okay, of course we have summation. We can write summation here. We take 1 by 4 outside of the summation. Okay, okay. Now split. 1 by 4 into sigma k square. Okay. 2 times sigma k plus sigma 1. Okay. We split the sigma, all terms. And sum is up to 10 terms only. 1 to 10. Here also 1 to 10. Here also 1 to 10. This is equal to 1 by 4 times. Okay, what is the formula? Sum of the squares of first and natural numbers. N into n plus 1 into 2n plus 1 by 6. So up to 10 terms. 10 into 11 into 21 by 6. That is 2n plus 1. Plus 2 times, okay, this is n into n plus 1 by 2 plus, and you know that sigma 1 to 10 1. What it means? 1 plus 1 plus 1 plus etc. 10 times, okay, you will get 10. Okay, come on, simplify it, say the answer. What is the answer? Come on. This is equal to 1 by 4 times, okay, this 6 is 2 into 3, 2 goes to 10, 5 times, 3 goes to 21, 7 times, we have 35 into 11, 35, 35, 5, 8, 3, this is 385, plus, here these 2 cancelled, we get 110 plus 10. Come on, do it. 120 plus 385. 385 plus 120. Okay, sum this. 5, 10, 5. Okay, this is 1 by 4 times 505. Okay, that is not the answer because in the answer you need only A, but it is given that this is equal to 5 by 12 into A. So what is A? This is given as 5 by 12A. 5 by 12A is equal to 1 by 4 times 505. So what is A? Okay, you can cancel this 5. 101. You can cancel this 4 3 times. Bring this 3 to right side. 3 times 101. Answer is 303. Got it? Yeah. Yes, that is the answer. 303. Okay? Is that choice is given? Not given? Yeah, of course it is here. 303. Okay. So I will say once more. Okay. It is given that in the question xk. Actually it is an easy question. Why? Because the kth term is given. No need of finding the nth term. It is given in the question. Okay. What is it? It is 1 plus 2 plus 3 plus k by k. Okay. We use a formula. We find k plus 1 by 2. Okay. S1 square plus S2 square plus S10 square. We write sigma sk square. It is k plus 1 whole square by 2. Okay. We can write, we expand that. Okay, okay. Without expanding also you can do this. Okay, take 1 by 4 outside. Yes, yes, you can. Take 1 by 4 outside. So 1 by 4 into k plus 1 whole square. Put k equal to 1 to 10. You will get 2 square plus 3 square plus etc. plus 11 square. Then how can you sum that? 2 square plus 3 square plus etc. plus 11 square. Yeah, that can be written as 1 square plus 2 square plus up to 11 square minus 1. So you use only one formula. That is for 1 square plus 2 square plus etc. plus 11 square. Of course, you can also do that. That may be more easy. Okay. And this is also not so much difficult. Okay. We just write a plus b whole square. We expand this. Okay. We supply sigma to all the terms. Write the formula. Simplify this. Okay. Of course, you are right. You can write like this. How? Take 1 by 4 outside. K plus 1, put k equal to 1. You will get the first term 2 square. Put k equal to 2. The second term 3 square. Etc. up to 11 square. So there 1 missed. Okay. So add that and subtract that. And write only one formula for 1 square plus etc. plus 11 square. And simplify that. Okay. Both the way you can do. Answer is 3 not out. Okay. Clear? Okay, okay. Go to the next question. Okay, go to the next question. What is it? Yeah, of course. We can't explain all the questions in this like this. Okay? There are so many questions. Past year, NEET, G main questions. You can collect questions from series. There are so many questions. Do it. And of course, you can ask the doubt. You can put the doubt in our doubt clearing class. Okay? That is an online class. You can live class, you can ask the doubt. Okay? So, go through all the questions. Try it. If you don't get the answer, if you feel difficulty, you put that question for the doubt clearance class. Okay? You can ask. Then we can discuss the question there. Okay? Here we have a limitation. Okay? I am discussing similar questions only. Okay, I am discussing similar questions. Okay, various type questions. There are so many type questions. I am taking one from each type. Okay, this is also a previous G main question. Here, one thing is clear. The pattern is clear here. Every term is in the pattern. Okay. So, it's very easy to find the nth term. Find the nth term, un. We have 3 type of terms. One is 3, 5, 7, etc. We know that is 2n plus 1. And next one is 1 square plus 2 square, 1 square plus 2 square plus 3 square plus etc. So, in the nth term, it should be 1 square plus 2 square etc. plus n square. And in the denominator, it is 1 cube. It is cube. 1 cube plus 2 cube plus etc. plus n cube. Okay. And in the denominator, it is 1 square plus 2 square plus etc. plus n square. Okay. It seems to be a very big question. Okay. Okay. Don't afraid. See, we use everything here. 2n plus 1, odd number of terms. Here some of the cubes. Here some of the squares. But one is in the numerator, one is in the denominator. Certain terms cancel. There remains only few. Okay. Simplification should be easy. This is equal to 2n plus 1 into, what is this? Sum of the cubes of first and natural numbers. N square into n plus 1 whole square divided by 4. Okay. And what is this? This is n into n plus 1 into 2n plus 1 by 6. Okay. We write all the formulas. Okay. Who are cancelled? This 2n plus 1 and this 2n plus 1 cancel. 1 n here and this n cancelled. 1 n plus 1 here and this n plus 1 cancelled. What remains? What remains? In the numerator we have n into n plus 1, of course. N into n plus 1. N into n plus 1. Okay. And this 6 go to the numerator, okay? 6 go to the numerator. 6 by 4. Of course it is 3 by 2. So un reduced into 3 by 2 times n into n plus 1. 3 by 2 times n into n plus 1. Of course you can simplify that as 3 by 2 times n square plus n. 3 by 2 times n square plus n. Okay. And find the sum. Up to 10 terms. We need to find the sum up to 10 terms. Okay. So we need S10. S10. Okay. S10. S10 is equal to 3 by 2 into sigma n square plus n is equal to 3 by 2 times sigma n square plus sigma n. Okay. Sure, summation is from 1 to 10 only. Okay. This is equal to 3 by 2 times, what is this? N into, n is 10, n plus 1 into 2n plus 1 by 6. And here it is n into n plus 1 by 2 only. Okay. Simplify. 6 is 2 into 3, 2 into 3. Okay. This 3 goes to 21 7 times. 2 goes to 10 5 times. 5 into 7 55. 35. 35. That is into 11. We got 385. So this become 3 by 2 times 385 plus this is 55. Okay. This equal to 3 by 2 into 5 plus 5 10. 8 plus 5 13 plus 1 14 and 3 plus 1 4. So 3 into, answer is 3 into 220. 3 into 220, isn't it? Okay. This is equal to 066. Okay. It's a beautiful answer. 660. Yes, what is the choice? Not in the choice. Here it is. It is here. C. C is the answer. Okay. Yes. Need to say again? It's not a tough question. Of course, I will say once more. Okay. A quick revision. Okay. From the given question, we can write the nth term very easily. We write the formulas for all the terms. We simplify. We get 3 by 2 into n plus 1. That is 3 by 2 n square plus n. Okay. Here in the bracket we have sum of cubes of first n natural numbers. And in the denominator we have sum of squares of first n natural numbers. Actually the question is very clear. Okay. It is in a clear pattern. Okay. That is why we write simply this. And we replace the formulas only. Simplify it. Simplification also is not tough. Okay. So many terms cancel. We are happy. Okay. We are happy. All the terms in the denominator will cancel. Okay. There remains terms only in the numerator. But that is a constant. 2 is a constant. No problem. Okay. And we find the sum. 3 by 2 sigma n cube plus n square plus n. We split sigma. We write the formulas again. But here n is equal to 10 only. We simplify. We get the answer 660. Answer is 660. Okay, that is the third choice. 660. That is only the third choice. Okay. Of course, you can ask your doubt in the doubt clearance class. Okay, that is a live class. Okay, that is not a recorded class. Yeah, that will announce, doubt clear, in each section, we will announce the doubt clearance class. That is a live class, you can attend, you can ask any questions. Okay, so what you have to do, go through the questions like, collect every question. If you see a question, check whether it is a question from the particular chapter or particular section, you collect that question in your section. In your notebook, you write a heading, summation of series, questions, previous questions from summation of series. And if you see a question, if that question is from summation of series, when come write in your notebook that question also and try it. If you can do that, well, okay. If it is a difficult question or if it is very difficult, you can pause that question in your doubt clearance section. Okay. Okay, thank you. That is it. Okay, we will continue a section of this by discussing only questions of this summation of series. Okay, that will announce continuous questions from summation of series. We will discuss some more questions. Okay. Okay, of course, that is not enough. You have to work. Okay, then only you will get. Okay, you work with the question, similar question. Of course, if there is doubt, you can ask that question. You can pose that question. We will answer. Okay. Okay. Thank you. Thank you all.